Bismillahirrahmanirrahim. Welcome students. Today we will continue Article 2.4 Terms associated with motion. In today's lecture, we will get familiar with the term acceleration, its kinds, its types, and we will be using different examples to learn more about it. So, can we feel acceleration? I got these very interesting pictures from the net. Yeah, they are actually very interesting. So suppose you are moving at 500 miles per hour east in an airplane without any turbulence. There is no acceleration as velocity is not changing. But however, what if a plane hits an air pocket and drops 500 feet in 2 seconds? And there is a large amount of acceleration that you're going to feel. And this is a sort of feeling that you're going to get. So it doesn't matter whether you speed up or slow down, it is still considered a change in acceleration. So in daily life, we observe things like speeding up, slowing down, and changing directions. It's all acceleration. For example, in this first picture, truck that begins to move from a stop position or speeds up to pass another car is accelerating. That is, it is speeding up. In the second picture, a car decelerates. That is, it's slowing down when it stops at the red light. In the third picture, a cricket ball changes its direction as it is hit. The magnitude of velocity is also changing. It was speeding up when it was moving towards the batsman. When it was hit, its velocity increased while moving up in the air, and then gradually it slowed down while coming to the ground. So we can say that acceleration can result from increase or decrease of velocity or change in direction or both. Acceleration is a vector quantity. So acceleration is the rate of change of velocity. It means when velocity of object changes, the object is accelerating, as we saw in the previous examples. But in yesterday's lecture, I said rate of change of velocity means that the velocity can change if there is a change in magnitude, if there is a change in direction, or if there is a change in magnitude and direction. So since acceleration is a change in velocity, so will it change too? Yes, by change in magnitude, not only will the velocity will change, but you are going to observe a change in acceleration as well. Similarly, in case of direction, and if both are changing, definitely there is going to be an acceleration. Let's get familiar with the term acceleration. So rate of change of velocity is acceleration. Keep in mind, whenever we are using the word rate with any physical quantity, it means we are discussing that physical quantity with time. So over here it's written rate of change of velocity. It means we are discussing velocity change with respect to time. It is a vector quantity because it requires magnitude as well as direction. Its unit is meter per second square. You can represent it by a small letter A with the arrowhead since it's a vector, or you can use a bar, or you can write it in bold letter. You can use a cap over it as well. The formula for it, acceleration is equal to change in velocity divided by time. So change in velocity, we will discuss it in detail. And last example, riding your bike forward harder to speed up and then riding your bike pushing brakes to slow down. These are all examples of acceleration. So there are two kinds of acceleration, positive and negative. In the first picture, the car's velocity is increasing from 30 kilometers per hour to 60 kilometers per hour when it is moving towards east. It means the car is accelerating. It is speeding up. In the second picture, the car is again moving, but the magnitude of velocity is same, 60 kilometer per hour. Over here, it's again 60 kilometer per hour. It is moving, it is speeding up, its acceleration is changing because its direction is changing as it turns. In simple words, when a car is moving in a circle, its velocity is changing. So by change in velocity, we don't mean the change in magnitude. We mean the change in direction. Whenever there is going to be a change in direction, there is going to be a change in velocity, and there is definitely going to be acceleration present there. And in case of third picture, this car has acceleration because its velocity is decreasing from 60 km per hour to 30 and then 0. Decreasing velocity is negative acceleration, which is also known as deceleration or retardation. So the difference between acceleration and deceleration: acceleration refers to an increase in velocity. Deceleration refers to a decrease in velocity. Acceleration is positive when object is speeding up. Deceleration or retardation is negative when an object is slowing down. Acceleration is in the direction of motion of object when it's speeding up, and deceleration is in opposite direction to the direction in which an object is moving. You can see the pictures over here. The car, it is moving with an increasing velocity towards east. Hence, acceleration is there because its velocity is continuously changing even though if its direction is not changing. Over here, suppose the car, while moving, suddenly applies brakes. So the velocity decreases from some value to 0. However, acceleration is going to be in opposite direction to that of velocity, and we will be using a negative sign to represent it. So let's calculate acceleration. As already discussed, the formula for acceleration is change in velocity by time. Mathematically, if you want to write it in a formula, change, for change, we use the sign delta. So whenever we use this delta sign with any physical quantity, it means we are talking about a change in that physical quantity. Suppose if I would have written delta t, it means we would have discussed, or we would have been discussing, a change in time. Over here, since delta is written with v, it means we are discussing a change in velocity. Now, since velocity is rate of change of displacement or positions, so you know if the position is changing, it means the magnitude is changing or the direction is changing, there is going to be a change in velocity. So delta V over here is equal to Vf minus Vi. Vf is the final velocity of the object. Vi is the initial velocity of the object. Final velocity means the velocity of the object at the end of any event. And initial velocity is the velocity which is at the start, which we observe at the start of an event. And t over here represents time. So let's see how acceleration can be positive and negative. There is an example. Suppose a car starts from rest and attains a velocity of 80 meters per second in 20 seconds. What is its acceleration? Now you have to dissect this question according to your requirement. Since this is a whole event given to you, that a car is starting from rest and it is attaining a velocity of 80 meters per second in 20 seconds. You have to find the acceleration. This part is pretty easy because you know A is equal to question mark. But what about the rest of the terms? This is also easy, 20 seconds. This is the time given. Now suppose a car starts from rest. So there's a hint given to you that initially when the car was at rest, and then you started it from rest, obviously when it was at rest, its velocity would have been 0. So you will write the initial velocity of the car as 0 meter per second and attains a velocity of 80 meter per second. This is the final velocity of this in event. That is at this interval, at the end of this interval, 20 seconds, the velocity came from 0 to 80 meter per second. So the final velocity is 80 meter per second, time 20 seconds. So you can have a little bit of idea that from 0 to 80, it means your velocity was increasing. So acceleration should have been there, definitely, and it would have been positive value. So this is a rough idea that that you should be having in your mind. So let's see if our idea is correct or not. You will use this formula: A is equal to VF minus VI by T. VF 80 minus VI 0 by T. You do the calculations and you end up with the result. So 4 meter per second square. Yes, this is the acceleration. It's a positive value. And since velocity is increasing, we have positive acceleration. So it means that acceleration will be in the direction of increasing velocity. Now suppose another example, a car is moving with uniform velocity. It means, uniform velocity means that there is a change, there is, the body is covering equal distances in equal intervals of time in a specific direction. And yes, this is happening over here. So it was moving with a uniform velocity of 20 meter per second. But suddenly it came to stop. There was a signal or there was a board and the car had to stop in 20 seconds. What is its acceleration? This part is pretty easy. As you know, you have to find the acceleration, but what about the rest of the part? It says with uniform velocity, this is the velocity that is given at the start of the event. It is 20 meter per second. This is going to be your initial velocity. VI is equal to 20 meter per second. And it comes to stop. When a car comes to stop, definitely its velocity is going to be 0. So at the end, in the end of 20 seconds, the final velocity decreases. It gets 0. Time 20 seconds. You will apply the formula. So you can do a bit of guesswork over here that velocity was 20, but then it obviously it went to 0 because the car stopped. It means that the velocity decreased, and decreasing velocity will give us an acceleration in opposite direction. And will it be having a negative sign or not? Because we say it is deceleration. So let's see if we will be getting a negative sign or not. So we're going to solve it. A is equal to 0 minus 20 by 20. You end up with minus 1 meter per second square. Minus 1. This represents the negative acceleration. That is, acceleration is in opposite direction to that of the velocity, decreasing velocity. Obviously, the velocity is decreasing from 20 to 0. Acceleration is in opposite direction. The minus sign over here is representing acceleration in opposite direction to that of decreasing velocity. So can acceleration be 0? If you're not moving, that is parked car, and if you're not moving at uniform speed, let's see about parked car. You know, we have discussed in previous lecture that velocity depends upon change in position with respect to time in a specific direction. Since you are not moving, you are not in a specific direction, your position is also not changing, so velocity is going to be 0. And since acceleration is rate of change of velocity, so when velocity is 0, then acceleration is going to be 0. So yes, if you're not moving, acceleration is going to be 0. And secondly, if you are moving at uniform speed, let's see this example over here. This is the example we did discuss yesterday when we were doing uniform velocity. We were discussing it. So if you remember, I said that let's see a car moving between 2 points and it covers 5 meters in same time interval, that is 2 seconds, 2 seconds, 2 seconds. Every 2 seconds, it covers the same distance, 5 meter, 5 meter, 5 meter. And if you actually calculate the magnitude, velocity at this interval comes out to be 2.5. Over here again 2.5, and over here again 2.5. So if you want to find the acceleration, obviously that is going to be between 2 points. And suppose the car is moving from this point to this point. Consider this is an initial point, initial velocity. Over here you're going to take the final velocity. So 2.5 minus 2.5 divide by time. So it is going to be 0. So yes, acceleration is then going to be 0. So it means when your speed is uniform in a specific direction, your acceleration is going to be 0. So what is meant by uniform and non-uniform acceleration? Let's say a car is headed east, and this in this picture, and let's say at 6 a.m. The car traveled 40 miles per hour, 7 a.m. 50 miles per hour, 8 a.m. 60 miles per hour towards east. And then if you want to find the acceleration, if you find the acceleration from 6 to 7 a.m., it was very simple. Vf minus Vi by t. So Vf is 50, Vi is 40, divide by t. T is going to be 1 hour because 6 to 7, 1 hour just, and there was a difference of just 1 hour. So 10 by 1 is going to be 10 miles per hour an hour. So the acceleration between these 2 points is going to be 10 miles per hour an hour. And over here, if you want to find the acceleration between 2 points, again, t minus 50, then there's a difference of 1 hour between the time. So again, you are going to get 10 miles per hour an hour. So the acceleration did not change. Such an acceleration is called as uniform acceleration. And in this picture, if you see, car is headed towards east, and at 6 a.m., the car covered 40 miles. It was moving with a velocity of 44 miles per hour. Then at 7 a.m., the car was having a velocity of 50 miles per hour, and at 8 a.m., suddenly 75 miles per hour. So if you find the acceleration between these 2 points, this is going to be your final velocity, this is going to be your initial velocity. So 50 minus 40 divided by time, which is going to be a difference of 1 hour. So 10 by 1 is going to be 10 miles per hour an hour. And over here, if you're asked to find the acceleration, it's going to be like 75 minus 50 divide by 1, because the difference is 1 hour. So the answer is going to be 75 minus 50. Okay, 25 miles per hour an hour. Or we can say miles per hour square. Not, I guess it's correct, yeah, miles per hour square. If I say miles per hour and hour, or miles per hour square. So yes, the acceleration did change. Over here, it was 10 miles per hour an hour. Over here, 25 miles per hour an hour. Acceleration is not constant. It is non-uniform. So this is the definition, that a body has non-uniform acceleration if it has unequal changes in velocity in equal intervals of time. Yes, there was an unequal change in velocity. Over here, it was 10. Over here, it was 25. And in case of uniform acceleration, over here, between these two intervals, it was 10. Again, in these two intervals, it was 10. So yeah, it's pretty much it. Uniform acceleration and non-uniform acceleration. So the summary of today's lecture, acceleration is rate of change of velocity. Acceleration can result from change in velocity, change in direction, or both. There are two kinds of acceleration. When body is speeding up, acceleration is positive. When body is slowing down, acceleration is negative. The types of acceleration, uniform and non-uniform acceleration. Uniform acceleration has acceleration constant. Non-uniform acceleration does not have acceleration constant. Okay, the home assignment is you have to revise the lecture. You have to write the differences between acceleration and deceleration, and you have to write a note on acceleration. So that was today's lecture. I hope you got the lecture. So see you tomorrow. See you in tomorrow's lecture. If you still have any queries, you can contact me on my WhatsApp number. Take care. Allah Hafiz.